All right. Afternoon, everyone. You're welcome to another edition of Software Bootcamp, organized by QualityTechies. We are excited to have our guest speaker today in the person of Adewale Akinlagun. I'll be reading his profile briefly. Just give me some minutes while I open up his profile. So Dewale has been a wonderful colleague. I'll still keep referencing what I mentioned yesterday about you keeping a good connection. So I'm friends with Adewale, and I had the opportunity of inviting him to come and take us through a training session today because I have been able to build a good connection with him in the past. Myself and Adewale worked at UBA, and I remember those years. He was really helpful. He was the team lead as at then. So I'll go ahead to read his profile. Adewale Akinlagun is a seasoned software quality assurance engineer and a QA manager with more than 10 years of experience in enhancing business solutions through rigorous testing and technical support. He has led quality initiatives for major organizations, including InterSwitch Group, HP, and Zone Network, where he specialized in optimizing system reliability and diagnosing complex application issues. Adewale is an expert in both manual and automated testing frameworks, including Cypress and Selenium, and is a certified ISTQB foundation level professional. Beyond his technical expertise in API and database testing, he is a passionate advocate for process improvement, shift-left methodologies, and fostering leadership within the QA community. Please, at this moment, can you make welcome Adewale Akinlagun? You can drop your emojis. Indeed, we are blessed to have him in our midst this evening. And I want to, this is not the hype, but I want to tell you that you're really in for an interesting dive as it takes us through today's topic. Please, Adewale, please, can you have the floor? I'll stop sharing now while you share your screen. Hi, Adewale, are you still on the call? Hello, everyone. Am I audible?
Yes, we can hear you. Good evening.
Okay, good evening. I just handed over to him. I don't know why he has not, he's not responding. Let me try to reach out to him on the phone. Hello, Adewale, are you back now? I think I'll just go ahead and share my screen back. Confirm if you can hear me. Can you hear me? Hello?
Yeah, we can hear
you. Yeah, I can hear you.
Okay,
Hear me.
Adewale, are you back? I think he was unmuted just some minutes ago. I heard his voice. Hello, Adewale.
Hello, Adenike, can you hear me?
Yes, I can hear you. Are you back now?
Yeah.
Your voice is breaking.
Can you hear me?
It's the network.
Yes, we can hear you. Can you
Yeah,
share
I
your
said
screen?
permit me. I might not be able to talk. Yeah. Permit me. I may not be able to turn on my camera. So
Okay,
that
there's no problem. So
yeah, I'll send you.
so can I stop sharing now while you share?
Yes, please.
Okay. All right, go ahead and share your screen.
Okay. Mm, sharing. Hello?
I'm Google just call it.
Can
It's
you?
a
Okay, I'm not talking. All right, the person is already muted.
Yeah, hello, Adenike, can you hear me?
Yes, I can hear you.
Yeah, I've sent a request to share my screen. I don't know because I'm not able to share directly. Request has been
We
sent.
just I'm trying to see the request.
Okay. I'll just stop sharing. Hello?
Oh. I believe you get on it. Adi, joko na bisa. Udah dem pada.
It came up. Green. The red has gone to green. Let me sit down. Yes. Hello? Can anybody hear me?
Yes, we can hear you. Good evening.
Yeah, apologies. Good evening. My network has been timing off. I had to just switch between networks now. So, yeah, I'm very sorry about that. Very, very sorry. I don't know what's happening. It's actually MTN 5G, and it's actually
All right, we can see your screen now.
exactly. Sorry, I had to even switch to another location right now. Sorry.
Apologies for the delay, everyone. So
Yes, apologies for the delay. Okay. Yeah, at least please let me know when you can see my screen. Even if you don't want to speak, you can just give a thumbs up. I should be able to see it also, so that I can start. But please, can everybody confirm that you can hear me clearly and there are no okay, all right, thank you so much. Good evening, everyone. And thank you to Quality Techies for giving me this opportunity to um train, especially in the area of software testing. I know yesterday he started the program, and today's another day two. Also thank you, Adenike, for the nice introduction. I know we've come a long way, especially in this area that of software testing that we're talking about today. So apologies, I might not be able to share my camera so that I will be able to maximize my network, because I'm currently actually not at home, so I'm actually just using a 5G router outside, but apologies to that. So please, you can also still confirm that you can hear me while I continue with the presentation. You can give a thumbs up. You don't necessarily need to speak. Can you all hear me so that I can continue? Okay. Okay, so welcome to day two of software testing. I know yesterday, based on some of the deliverables from yesterday, we looked at the basic understanding of what software testing is, the importance of software testing, also why software testing is important, the concept of QA, QC, and testing, and then the various software testing methodologies. So those were the things that were covered yesterday. But today basically we'll be looking at another area in terms of the principles of software testing, software testing types, software testing process, and then shift left testing. So these are the areas that we'll be covering today. And as we go along, if there are any questions, any area that you feel that you are not so clear about, you can then please take notes, and then we can always have questions at the end of this session. So while I go into it, so we are talking about principles of software testing. So there are certain principles that guides software testing, and they are like foundational guidelines that help every QA team. There are foundational guidelines that help every QA team to test effectively, because for every person that is going into the QA space, there are certain guidelines, there are certain principles that we need to be able to understand from the very beginning, from the get-go, so that you can sorry, apologies for that. You can understand what testing is about and how to test effectively. And there are seven principles. There are seven principles. These principles have not changed. I remember when I first saw this principle in 2015. Yes, 2015. Yeah, I saw these principles, and these are some of the things that were first taught in becoming a QA person. So one of the principles is that testing shows presence of defect. Exhaustive testing is impossible. Number 3 is that early testing saves time and money. Number 4 is defect clusters together. Number 5 is beware of pesticide paradox. Number 6 is testing is context dependent. And then number 7 is absence of error is a fallacy. Absence of error is a fallacy. So we'll be looking at these 7 principles in depthly and understand what these 7 principles actually mean for a QA person or for QA teams in general. So number 1 says that defects, they're always defect. You know, when we said testing shows presence of defect, that so when we say testing shows the presence of defect, what this actually means is that testing actually is supposed to review bugs. It's actually the objective of testing is that you want to show or prove that a system is not completely bug free. So you as a tester, your job is to look out for bugs or for defects in any system, because we want to ensure that you are able to explore all the possible scenarios for you to be able to check out this system and say that, oh, this is so when we say testing defects, testing shows the presence of defect and not the absence of defect. What we are trying to say is that, for example, I'll be using some examples so that we can picture some of these things. Please, can you confirm you can still hear me?
Yes, you can.
Okay. So where we say testing shows the presence of defects and not the absence. So for example, when you are testing a login page, I would like us to visualize a login page, for example, and you test that login page with a valid credential and invalid credentials. And then you do not find any issues. You understand? You might feel that, oh, the system looks defect free, bug free, for example. But that does not guarantee that even when you test the login page with maybe the username and the password and everything looks fine, the correct error message is gotten and all of that. But the truth is, you are not sure whether when you do a password reset or a session management or something that has to do with the security of the application, that there's no guarantee that you wouldn't come up with a defect or a bug. So we see that the whole thing about defects is testing is that it shows that there's always the presence of defect and not the absence. Also, number 2 says that exhaustive testing is impossible. So what that means is that you cannot completely 100% say you tested a system. Like it says, like testing no they finish. You know when they say the pidgin parlance that problem no they finish. So it's the same also in testing, that you cannot exhaust testing. That no matter what you try to do, testing does not finish. And that's why in testing, you always try to use some form of risk and priorities to actually focus on what is important most of the time, because sometimes there are tight deadlines. Sometimes you want to be able to ensure that, oh, we are building an application, we want to be able to go through testing and maybe deploy and push to market by December, for example, because in this IT space, there's always deadlines, there's always wanting something that you want to push to market and all of that. So it shows that you cannot test all possible inputs. You cannot test all possible input, all possible scenario, and all possible combination. So for example, if you are to test, for example, a date field, I'm using a date field, for example. Maybe there's a date field in a registration form, and you want to test, and you know that when we look at the date range from 1900 to 2100, for example, that means if you look at that range shows that you have thousands of possible values that you can test, because you can start testing from 1900 to 1901, 1902, 1903, 1904, 1905, up to 1920, 1921, and all of that up to year 2100. So what that shows is that you cannot test all of those possible inputs, because there are things that has to do with timing, deadlines, and all of that. And I know as you go along in this training, you get some of these things. There's something we call boundary value and equivalence partitioning. Those are the things that you use to help perform risk and priority on the system to be able to say, okay, with this multiple input I have, how can I break it down and test every possible scenario in that equivalent or in that boundary or in that, as that case may be. Then number 3 talks about early testing. It saves time and energy. So you see that when testing starts from the very beginning, it helps to save time. So because you are able to catch defects early, there's something we talk about that catching defects at the very early stage is less costlier than when you find a defect at when the product is complete. And that is why you see, for example, that there's this thing about a tester being involved from the very beginning where you are even gathering requirements. And that's why you say that testing activity should start as early as possible in the software development lifecycle. So, for example, maybe in the requirements, it says that, oh, the users must be at least 18 years old to be able to register, for example. But during some implementation, the developer already is trying to implement a minimum of 16 years. And then in the requirement, it's saying 18 years. But when you're able to itemize all of this and find it out during requirement review, at that point, it's cheaper to solve. It's cheaper to solve. So at the end of the day, you are able to nip that kind of bug at the early stage, rather than waiting till when you get to the point where the application has been developed, and then you now start to look at, this thing should have been 18 years, and now you're seeing 16 years. And then the developer has to go back and fix that issue. And then you discover that there's a lot of time that has been wasted on something that should have been captured earlier during the requirement gathering phase and the requirement review. Because at that point, testing would have started, testing would have seen, oh, this requirement is not testable. Oh, this requirement is not what it's supposed to be. This is what it is. And then everybody is in sync, and then we're able to move on. Then the 4th one says defects clusters together. We've come to realize that a small number of modules, most of the time, usually contain most of the defects. And that's how you discover that 80% of most defects are found within 20% of a module. So I'll give an example. For an e-commerce platform, for example, that has about maybe 100 modules. So what I mean by modules, you could have the login page, the shopping cart page, the registration page, this and that, the maybe payment modules and different modules. You discover that in that e-commerce platform, you could have about 70% of the production issue coming from maybe checkout or coming from when customers are trying to make payments. So it could be around the payments module. So you see that these are the areas, especially when you look at those areas that have that large concentration of issues or defects. Those are the areas that concentration should be given more to. So number 5 talks about the pesticide paradox. Pardon my this thing, pesticide paradox. So we see that most of the time when you run the same test repeatedly over time, that test will stop finding new defects. When you run the same test repeatedly over time, you will discover that it will stop finding the same defect. And that's what the pesticide paradox talks about. I don't know if many of you have discovered that there's a point in time, I'll use the example of mosquitoes. You discover that there's a particular insecticide that you always use for mosquitoes in your house. And maybe there are some mosquitoes that have maybe gone to hide in some places, and they've become so, I don't want to use the word, they become so strong that they've become so resistant. You don't discover that insecticide no longer works after a while for some kind of mosquitoes in your house. And you now discover that you need to get another type of insecticide because they've grown resistance to it. And that's what the pesticide paradox talks about. That you discover that the same test, when you continue to use that same regression suit, same set of test cases over time, without making modification, you discover that test will continue to pass and you will not discover new bugs because no new test cases were added, or there were no proper review or proper updates to those test cases. So that's what the pesticide paradox talks about. Then the number 6 principle of software testing talks about the fact that testing is context dependent. Testing is context dependent. That means that you cannot take the same approach when you want to test different applications. Because, for example, when you are looking at testing a banking application, you will discover that for a banking application, you require more extensive tests around security, around compliance, around transaction, and what may you have. But when you want to test a gaming application, no, you are not really focused about those things that you did about for a banking application. But for a gaming application, you are focused more on performance. You are focused more on usability, and you are focused more on user experience. Because for a banking application, you can get by with user experience. For example, but for a gaming application, the case might not be, because a gaming application requires more on performance or more on how usable it is and user experience. So you discover that when you want to test, the strategy to test a banking application would differ from testing a gaming application, because you want to look at what is the product risk and what are the objectives. So those are the things that you would look at. And then the 7th principle talks about absence of error fallacy. Absence of error fallacy. What that means is that a system with few or no defects doesn't necessarily mean that the system is ready. Because you can test an application and it passes every test, and at the end of the day, that system can still fail if the wrong requirements were built or the key scenarios were never tested. So, for example, I'll use a loan application. A loan application might work perfectly according to your specifications, but the customer might not be able to complete maybe the application process due to poor usability, for example. So it might be a case of, oh, everything was built according to specification, the whole thing, but when it lands on the user's hand, the user is not able to use it properly to even complete a process or complete an application to even onboard, for example. So you see that the fact that you do not see a defect from, oh, I'm not able to log in, oh, the login is coming up with this error. Provided you don't see those defects, does not necessarily mean that the system is error-free. It just means that you've built a system according to specification, but you've not built it, maybe you've not built it right according to requirements. So those are like so that does not mean that when there's no bug in a system, it doesn't always translate to a good product. The fact that you've tested there are 0 bugs doesn't mean that there's because the job of a tester is not necessarily to just test for bugs alone. It's not just to test that, oh, there are no bugs in this system, but you are testing that, oh, this product, did we build it right? And does it work as intended? Not just you want to prove that, oh, I cannot log in, or when I log in, oh, I discovered that an error message was got. Oh, when I log in with a blank password, I was able to log in successfully. Those are not the objectives, because at the end of the day, you want to be sure that you are building the right product and that it works according to specification and it works as expected. Please, can you confirm you can still hear me? Good, thank you. Okay, so let's go to, sorry. Okay, so we've looked at the 7 principles of software testing, from defects, exhaustive testing is impossible, early testing saves time and money, defect clusters together, pesticide paradox, context dependent, and then absence of error fallacies. So I'll reiterate again. The whole essence of why you are a QA, you are a software tester, you're a quality assurance analyst, you're an automation engineer, whatsoever, nomenclature, is the essence is that you are not just testing that this system is bug free, but that you are building a good product. So building a good product is ensuring that the system is bug free and also is built right, because the whole essence is that you don't want to just build a product that customers are not able to use. Oh, it's bug free, but customers are not able to use it. So you want to ensure that you are building what is right. You're building what, and I know that as you go on with some of these trainings, you see some of these things around building rights and all of that. So now we have software testing types, for example, and under software testing, you will come across all of these things a lot when you go full-fledged into it. And we have functional testing and non-functional testing. And when we do look at functional testing and non-functional testing, we are referring to, under the functional testing, we're referring to things that are, for example, that describe, you understand, the functional requirements in terms of the features, the functions, and the business rules, right? So when we are talking about functional testing, we're talking about things that describe what the system should do. And when we are talking about what the system should do, we're talking about the features, the functions, and the business rules. So you under functional testing, we have things like unit testing, integration testing, system testing, and then user acceptance testing. While for non-functional testing is about describing how well the system should perform rather than what it does. You know, we said functional is about what the system does, but non-functional looks about how well the system should perform rather than what it does. So for example, when we talk about non-functional testing, we're talking about performance testing and load testing. We're talking about security testing and compatibility testing. We're talking about scalability and reliability, and then usability and accessibility. Usability and accessibility. So when we look at so apologies, sorry. So when we look at the functional testing bit of it, we said that functional testing has to do with what the system should do. If you remember what I said about what the system should do, and in that model for functional testing, that's where we talk about the shift-left testing or the testing pyramid. It helps to visualize the different level of testing in a project and how much effort and what types of testing belong at each level. So when we look at, for example, at the very base level is what we call the unit testing. That is a fast and isolated form of testing. That's more of like testing things in their isolated state, if I use that word. So when we talk about the unit test, we're talking about testing things in the isolated state. So you are able to test more items, and you are able to, at that level of unit testing is where you discover all of the defects early on. So it's more of like a testing part where you test all the smaller parts of the application. And that's why we call it as unit. So for example, when we talk about an application now that has a login, has a payments module, has a transaction module. So it's at the unit testing level that you're able to isolate all of these and test them in their various units. You're able to test them in their various units. So that's what unit testing is all about. And then we now go next to the integration testing, which is also the second level. So the second, when you are able to test the individual modules differently, payments module, login module, registration or onboarding module, you are able to test those units independently. The next level is now the integration testing, and at integration testing, you are looking at testing the interaction between those various units or those various components. So for example, at the integration level testing, you are testing interaction between, for example, the onboarding module and maybe, for example, login, or you are testing the interaction between when you make a payment and when you check out, for example. So integration testing has to do with interaction between the different components. And then the next level is the system testing. You discover that as you go up, these things get smaller. They get smaller. So at the system testing level, you are testing the overall system from end to end. You are not looking at, okay, how does this system go from beginning to end? So that's what system testing does. That's what system testing does. And then the last level is the acceptance testing. So at acceptance testing level is more of we can see it more as a UAT. When you hear the word UAT, user acceptance testing, it's more of UAT, where basically it's more about validating business requirements. Most of the time, in depending on the different organizational structure. I know that Adenike mentioned when we're UBA. At that level, especially around the UAT testing level, what we do most times is the stakeholders, the business come, and then the QA and everybody sit down and then visualize what has been built and then go through it together. And then everybody either accept or does not accept. And I think this is built well according to requirement or is not built according to requirement. So that is it about the testing pyramid as regards functional testing. Then we now have to look at, we have two parts we mentioned in the beginning. The the non-functional testing that we talked about. We said non-functional testing types basically have to do about how the system performs rather than what the system does. It's about system performance. So for example, now the non-functioning type, we are looking at things like performance. You want to be able to measure what is the responsiveness and stability of this system. You are looking at things like load testing. You are looking at things like, you want to be able to ensure that, okay, can this system serve 1,000 users? Can it serve 5,000 users? Can it serve 10,000, 20,000, 1,000, 100,000, 1 million, depending on what the scope of requirement is for that system. You also want to be able to look at things like stress. You want to say, okay, can 1,000 users be on this system for the next 1 hour and that this system will behave as expected? And then we have spike testing also, which is about reactions restoring traffic spikes. Let's say there's a spike in the system. How does the system accommodate those spikes and how will I put it? Come back to itself, that kind of thing. And then also we looked at things like security. Security testing is also a non-functional testing type that has to do finding vulnerability system and how you are able to protect data. Because I've used several examples. For a banking application, the security must be very, very uptight because you don't want to allow intruders. They might not necessarily have to go into your core banking and steal money, but just by getting people's data is enough for that system to be compromised and all of that. Then we look at compatibility. This is based also on requirement, and that's why you want to say how well does this system behave. So you want to be sure that, okay, this app, can it work on or this web application, does it work well on Chrome? Does it work well on Firefox? Does it work well on Edge? You are looking across various OS and various browsers. Reliability testing also talks about consistent performance over time, scalability, accessibility, localization, maintainability, and portability. Adenike, are you here? Okay, can you all hear me? Okay, thank you for giving me that. So we've looked at all the non-functional testing types. We looked at the non-functional testing types. So I don't know if as I mentioned, please, if for all your questions, please, you can just note it down as I go through all of this with us. So the next thing we're looking at is the test planning. And when we are talking about test planning, because we've looked at the various forms of testing, but we discovered that test planning is also a very important process that helps us to define what the scope, what the objective, what the strategy, what the resource, what the schedule, and all the activity that has to do with testing a software application is concerned about. So because when you think about test planning, you are looking at it from what are the details that we need to ensure that we are doing the right thing as a QA person or as a QA team? Because what this does is to help you to plan ahead. It's more of a preventive approach than a reactive approach, because you want to be sure that you are able to control of the actions before anything happens. Because you want to be sure that, okay, what are the things that we can accommodate? What are the risks that can come? What are the things that we need to ensure that we identify on time quickly? So that's what test planning does. So as I said, test planning, you are just you are ensuring that, oh, at the end of the day, you want to get like a roadmap, So look at it as a roadmap for testing efforts. That's what a test plan or test planning does. So test planning is more of like a roadmap for testing effort. And what comes out, the byproduct of that is called a test plan. So when you look at the test planning process, you are just looking at a roadmap to look at, okay, what are the things we need to plan about? How many periods do we have? What are the risks that may come out from some of these things? Because we have 2 months for testing this application. What are the possible risks that we can identify and all of that? So that's what test planning is all about. So it helps you to ensure your objectives are clear. It helps you to identify risk early. So it helps you to identify risk early. It helps you to be able to define your roles and responsibilities. So you know who for what. You know, when we talked about functional and non-functional testing, the test planning helps us to be able to identify that, okay, we are doing functional testing. We are going to be able to test this application based on this and that. We are going to do system testing. We're going to do unit testing. Are we going to do performance testing? Are we going to do security testing? You are able to identify all of that in test planning. And you're able to assign, okay, this person is QA. You are the one working on drawing out a plan for our performance testing, this one, that, and that. So you're able to identify all of that and identify all the effort and the timeline. It also helps to improve communication among stakeholders, also to ensure adequate test coverage, So that is all of the things that a test plan does. So the next one in the test process that we're looking at is test monitoring and control. So we've talked about because there are certain steps when it comes to the test process. Number one is the test planning. The second one is test monitoring and control. So when we look at test monitoring and control, test monitoring basically is just the activity of tracking and evaluating that what we are testing in terms of the progress is against the test plan, and that we are on schedule and we are within the scope and we are meeting the quality objective. So you want to be sure that, are we on track? For example, are we on track? Are the test cases being executed as planned? What is the defect status? Are there any risks? Are there any broker? Is the product ready for release and all of that? So that is all of the things that we look at. Those are the questions that we answer from test monitoring and control, because you want to ensure that you are measuring the testing progress well. You want to ensure that you have been able to identify all of the possible risks and issues early on. You want to be able to ensure that you are tracking defects as early as possible. You want to ensure that you are right on schedule, so that even when you are not right on schedule, you can easily escalate and communicate some of this. And then you are also able to use this to provide visibilities to stakeholders, because the testing team does not work in isolation. You want to ensure that you're also providing visibility to stakeholders, and then it helps at the end of the day to help everyone on that project to be informed about the release decision. Because once you're able to communicate your own part, it helps you able to say, where are we being delayed? Are there issues? Are there blockers? Are there things that we didn't factor in? And then you're able to identify all of these things early on. So test monitoring and control is very, 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 very key and very, very important, because you want to be able to ensure that everything is being tracked properly. Then the next step is we call in the test process is called test analysis. So when we look at test analysis, for example, we are talking about the process of reviewing and understanding the requirement to help us to identify what should be tested and how it should be tested, right? So it basically happens most times before we start doing our test design and our test case creation. And this process helps us to ensure complete coverage of the requirement. So when you are doing the test analysis, you are reviewing the test basis. And what that means is that you are reviewing every document describing what the system should do, from requirement document to system and architectural design, to design detailed designs, to use cases, even source code if possible. Together, these are all the things that we call the test basis. So you are reviewing it at that point in time. So that's what the test analysis phase is. So at the end of the day, you are able to identify the test conditions because you're able to pinpoint the specific aspect or things that you can actually test. And this helps also to build what we call the requirement traceability matrix. We call it the RTM. That requirement traceability matrix is a way of mapping each requirement to test conditions so that at the end of the day, it helps you to be able to identify, okay, were this requirement actually covered, you understand, in our test review, you understand? So the whole objective of the test analysis process is to help you to understand system requirement early on and clearly. It helps to also help us identify the test conditions and test scenarios. You are able to also identify the defect gaps or ambiguities in the requirements, because when you see, oh, what are the things that are not so clear about this requirement, and then you're able to define what needs to be tested, right? And then you're able to ensure proper test coverage. Then the next phase in the test process is called test design. You know, I mentioned that before we go into the test design is what we call test analysis. So it's the test analysis phase that so in the test design phase, basically, there are very key aspects of the software testing life cycle. So the test design phase is more of converting, you know, we said from the test analysis phase we looked at earlier that you are able to build a feasibility matrix where you are able to map the test conditions back to requirements. So when you now get to the test design phase, you are now able to convert those test conditions and scenarios into test cases. So you're able to convert all of those test conditions, test scenarios into test cases, and then you're able to define how the test will be done. So you're able to, so the objective basically of the test design phase is you are able to create detailed test cases on the test conditions and scenarios. You are able to find expected results. So for example, maybe one of the conditions is user is able to you want to let me use the word for example, maybe one of the condition is or test scenario is login, for example, login scenario. I'm just using that as an example, login scenario. So in the test design phase, you are now able to identify and say, okay, if this is login, what are the things I need to test? Login, you said, oh, these are the requirements for login. The login requires email, and it requires password with this maybe 8 or 6 letters with 2 special characters and all of that. At least those have been defined from this requirement and mapped it to the test condition. And I'm able to say verify user can log in with email with verify user can log in with correct email and password. Yes, verify user cannot log in, for example, with not maybe an invalid email and a valid password. Oh, verify user can log in with a valid email and an invalid password based on those conditions that you've been able to see from the very beginning. So you're able to identify all of that quickly and those test cases properly. And then at the end of the day, it's clear for everyone because you already know what your expected results should look like. So that anything that varies away from the expected result is going to be an error or a defect. So now the next one is the test implementation. So the test implementation basically is the process of preparing everything you need to execute your test cases. So you are turning your all your ideas, all the things you have been able to put down into ready-to-use test cases, where you are able to identify all of that, finalize the remaining details, you write out the actual test steps or scripts, or you prepare the source data or the test expression so that you can hit the ground running at execution. And one of the objectives is implementation is that you're able to prepare the test environment, you're able to set up test data, you're able to organize test cases, and you're able to configure automation scripts if applicable. And all of these happen in the test implementation phase. All of this happens in the test implementation phase. So the next one is okay, we've talked about the functional. Yes, we talked about this. So apologies. This was functional tests and test levels. Okay, the next one is the test execution and completion. Test execution and test completion. So this, like, you can see that all of these phases are going in sequential order. All of these phases are going in sequential order. So in the test execution phases, test execution phase is basically where you run the test cases itself. That you are checking, does the system work as expected? Oh, I'm able to log in with username that is valid and a password that is valid. Oh, I'm not able to log in with a username that is invalid. Oh, I'm not able to log in with a user with a password that is invalid. So at the test execution phase, that's where you do all of your manual testing, or maybe a test with an automation tool, as the case may be. So you provided all of this, you understand, were designed and built as automated tests in the future state, because you can't just jump to automation if those things were not provided for in the earlier stage we talked about. But basically, that has not been provided. At this execution stage is mostly where you do more of all of your manual testing. So you execute all of the test cases that you have prepared from beginning to end, and then you compare with the actual result, and ensure that, oh, does this thing actually meet up to what we have actually said that, okay, oh, this is passed or this is failed, and all of that. And then the test completion basically is just the phase of you are formally ending the test cycle. So, for every test process, there's always what we call cycles. So, for example, you don't want to leave testing as an endless loop, right? You don't want to leave it as an endless loop where you're just testing and you're just testing, because the system is ready and it's built. You want to, and you're at that system testing level, you want to test everything from, maybe you have, for example, 50 test cases. You don't want to just keep it open. You want to test all of those 50 test cases and say, okay, out of these 50 test cases, 35 passed, 15 failed. And then you put up your defect and all of that, and then you are able to return it back to the development team, and then everybody sees, and then we come together and say, oh, this is a defect, this is not, this is that, and then we're able to identify all of this. And then once everything is fixed, it now goes into another testing cycle, which we now call, maybe, for example, a cycle 2. So that's what we do at the test completion phase. So you are basically just checking that what has been built, is it the right things, the right deliverables were produced and sent where they belong. Is more of, so the test completion phase is more of a formal sign-off, basically. You just want to confirm that, oh, are we fine? Are we good to go? Oh, I've tested these 50 test cases, everything is fine. Everybody's fine with it. Otherwise, oh, we go into another cycle and we test. And then is in that phase also, because you've tested, oh, we can't go live. Oh, there are defects. You now have to look at, okay, can we carry on the defect that were discovered in cycle 1? Can we carry it into the next release or project for fixing? Or do we need to fix it now and go into another testing cycle, into cycle 2, so that we are sure that all of these things are addressed before we go live? So basically, the test completion phase is more like a checking phase. You are just checking to ensure that everything is fine. And then also you are finalizing the test wear. So what we call the test wear are things like the test documents, things that you use for testing, the script, the data, and the related artifacts, so that you keep all of these things. They are properly archived or handed over to those who maintain it, because all those test cases are not just something that is a one-time thing. They are things that will always be made reference to For example, maybe you will go into another cycle 2, or we've implemented and iterated on the system, and we built more modules on the system. So you are not going to just be testing those new modules, but because we've tested before, we have maybe application version 1, and then we'll now build version 2. So version 1 test cases will still be relevant because there are things that we've used before. It might just require some level of review or update, and then you are able to now use it as a basis to also help for a regression for version 2. So this is where you finalize the test well. And then there's something we call handover and retrospective. For many teams that run the agile process, there's for the handover, basically we are just closing down the test environment and infrastructure and handing it over for either reviews by another part of the organization, or you're handing over any tests to the maintenance team for ongoing use. So it's just a way of just saying that, oh, we've tested, these are the test artifacts, these are the test things that we've done, and then we're just handing it over. Or retrospective basically is just a project review, a post-project review. Sometimes for some teams, for the agile teams, it happens like in a bi-weekly process. But for a project, for example, it can be, okay, after the 3-month project, after the 6-month project, then you conduct a post-retrospective. You are able to see, okay, what were the things that we did well? What are the things that we did not do well? What are the things we need to do? What are the things we need to stop doing? What are the things we need to repeat? So I don't know if there to this, yes. So I don't know if there are questions, there are contributions. I didn't. Are you there?
I'm still here, but there is so much noise. Someone is raising his hand.
Okay, please, you can go ahead. I don't know, Emmanuel. Emmanuel, if you can hear me, you can go ahead.
Good afternoon. Yes, I can hear you. Good afternoon. Please, can you hear me?
Yes, loud and clear.
Okay, there's a bit of noise here, so I had
Loud
to
and
go and stay in one corner. So my question actually is just regarding this um non-functional testing. So the part where you mentioned the security testing and all of that.
Yeah.
So I just want to ask, or I'm just curious about something. So we know that most organizations will have like a dedicated security team
Team,
or
yes,
security
that's correct.
department. Yes. So I'm just wondering, so these aspects now, is it going to be the responsibility of the QA, or is it okay to just delegate that responsibility to the security department to do? I mean, since to an extent they probably have better tools and better processes for ensuring the security
Tap my password and it's in the clear, right? For example, that is a security risk. Am I communicating, Emmanuel?
Yes, you are.
So that's a security risk. So you wouldn't say that, oh, because it is left for the security team, you wouldn't take note of those kind of things that are on that level of security that you can manage. You get what I mean? There are all the open testing and all of that. There are tools and all of that the security team will have access to, and they're able to do all of that. But there are some certain levels of security testing that you can do. You understand that you are, for example, if you enter a valid username and an invalid password into a system and the system grants you access, is that not a security breach on its own? It's a security breach, right? Or maybe, for example, you attempt to log in severally is based on, most systems, when you attempt to log in severally and it doesn't lock you out, that's a security breach, right? Because you are looking at it from the angle that if, for example, I log in with invalid credentials severally, the system should lock me out maybe for 30 minutes, for 1 hour, you get, and all of that. But if the system does not behave that way, that's also a security risk you get. Or you can reset your password on the system without proper security. There's a way you reset your password where you say, okay, when you reset your password, it tells you that, oh, an email has been sent or a code has been sent, and all of those processes are bypassed, and you can easily just reset your password without having to go through an email or a code. Or, okay, I've never seen one before, funny enough, where they said, when it got to the OTP page, it says, please enter your OTP into this page. And then the OTP was showing on the dialog box. You get, that's a security breach, because normally your OTP should either be sent to your email or your phone number. But already on that prompt that is saying enter your OTP, the OTP is already showing in clear text. You understand? Those are security issues that you as a QA can also identify without having to. So you are correct when you say that organizations have security testing teams that do those work for them 100%. I've worked in organizations, and most of the time, the team responsible is always like a security team that handles all of that. But also as a QA, you also should pay attention to some of these vulnerabilities that could occur from testing the system. I don't know if I have been able to answer your question.
Yes, yes, you did perfectly. Thank you very much.
Yeah, you're welcome. Chin or so.
Yeah, good evening.
Yeah, good evening,
Thank you
sir.
so much for the wonderful session. Yeah.
Yes,
Okay,
sir.
when you were talking about the STLC, right? Test plan. Let me just take you back to test plan. My
Okay.
question now is it in all cases that the tester must write the test plan? Yes, by the books. Yes, it's something that we need to do, but real world scenarios. Let's go to real world scenario. Is it in all cases?
Yeah, you're correct. You are correct. So it's not in, you are correct. So most of the time, where test planning mostly suffice is more of a project-based scenario, right? Or because when you're running agile sprint, for example, you don't actually come up writing test plan to say, oh, these are the things, these are the resources, these are the risk. You understand? Because the expectations have already been set clear from the very beginning. Because you have like a test strategy document already that is in place in every organization that guides some of the way you test, how you test, and some of the things that can occur. So those are like you get, but in real around when you are working in a project-based system where, for example, you want to go on a 3 months, 6 months, 4 months kind of testing process, and these are things that you want to most times project-based. Yeah.
Okay, so now when you write your test plan, is it
Yes.
just for your own consumption, or you have to share with the stakeholders? Now you're alone. When you write to the stakeholders, or just for your own
You are
adoption?
supposed to be able to share it with him or her so that you are able to review together and you understand, sign it off. Because in your test plans, you need to be able to sign it off with whoever you'll be reporting to. So that person also is able to identify, okay, this is what this person has said, or can our team accommodate this? Because in that, you'll be able to identify all of the risk, all of these. Because if you are a lone tester, that's a key man risk on his own already. Because it means that if, for example, that person resigns, or if, for example, you fall ill, it means that the project will be stalled, for example. So all of those things will be reviewed so that there are proper communication and proper things that can be identified to help guide against such risk. So that's why you need to share it with relevant stakeholders, especially for those who you might be reporting to directly.
Okay, thanks.
Yeah.
Okay,
Yeah.
one final question.
Yeah, no problem.
At what point does the test completion phase come into play? Is it at the end of your testing or the pilot? Cool. So what
Yes.
understand the difference?
Yeah. So it depends. Some of these things sometimes different organizations with the way they how will I put it? They carry on with the various testing process, right? Different organizations before production release, right? It comes before production release. So most of the time, I would say the test completion is basically like a phase before pilot, because pilot means that, oh, the system is ready, but we want to be able to release it to a small group of users, right? To validate it in a real world scenario. So pilot is more like a mini launch. So test completion would have happened before that, because test completion means that everything, you've tied up all loose ends, and we are saying that we are good to go, right? So, but the pilot, you just want to be able to identify, okay, can we test with 20 users, 30 users that are a close group? You understand? You want to be able to perceive some of the things that they would see, you understand? You want to be able to see real world behavior, you understand, and final validation. So test completion has happened. You have signed off to say, oh, everything is fine. The application is almost, as I said, it's not, no application is 100% bug free, but you have been able to say that, yes, this is perfect to a point. You understand? You signed off all of the documents. So pilot is after all of that, because pilot is, you are ready, but you don't want to deploy yet. You just want to carry it out with a small group of users to mimic real life behavior before you go live.
Okay. All right. Thank you. That will be all for me. Thanks.
Yeah, thank you.
I would like to
thank
add
you,
to that. Can you hear me? Hello?
Yes, go ahead.
Okay, so
yes,
I would like to buttress. Let me start from the second one. So it's good we start applying the principle of testing right now. So you could remember in what our speaker said. We talked about testing is context dependent. So it all depends on the organization. So in some organizations, I've been privileged to work in a bank and in a fintech tech. So when I worked in a bank where we use waterfall methodology, so when by their defined process, testing stops for me when I've been able to create my test report and I've generated that. That's when my testing stops. So it is the UAT team. There's a separate team called UAT team. They take on with the process from. So it's context dependent. It depends on the organization. My current organization where I work. So testing doesn't stop on test environment. So I have to go ahead to production. Just a minute, I'll try to mute where the noise is coming from. Okay, so testing does not stop at staging or test environment. So testing stopped when I've been able to deploy it, and post-deployment checks has been completed. So that is when my testing stopped. Then for your initial question that you asked about test plan, so I would still say it's still context dependent. It depends on the organization. In some organizations, you must always write test plan. Mostly in banks, they are very strict to their processes. So you must always create a test plan before you commence your test, and it has to be approved before you proceed. In some other organizations, maybe fintechs or some more relaxed organization, they use test strategy. So essentially, I'm just trying to let you know that it all depends on organization. It's not a cast a stone that is not, there's no tight or strict process. It all depends on what is allowed by the QA team of the organization. All right, thank you. That
Okay.
will be all from me.
Thank you.
Yeah, thank you, Adenike. I don't know, so that's clear, right? So that's why I brought it back to this context dependence, that the approach
Yeah,
depends
that's it's
on the
clear.
environment and product you get. For most fintechs,
Yes.
when you run agile environment, no, you don't have time to start writing test plan, because even when you're testing, it's like you should go live tomorrow, that kind of thing.
Mhm.
Yeah, so
All right. Thank you so much.
yeah, you're welcome. I think Miracle, you can go ahead with your question.
All right, thank you so much.
Yeah.
So first question is on the test plan too. So you mentioned that in it for a test plan you have to like you mentioned you have to consider security testing, like
Yes.
functional and non-functional testing.
Yes.
So you're saying that for a product that have like a lot of modules,
Yes.
so you're going to create a test plan for like everything about the product, the different models and the different type of testing that will be done in that model.
Yes.
And if yes, what kind of what's the best recommended way to document, like to document the test plan, to keep good record tracking?
Okay. I think if I get your question right, you're talking about the test plan based on, because you have a large application and you want to be able to document those things properly, right? Am I correct, Miracle? Hello? Can anyone hear me? Hello?
Yes, we can hear you.
We can
We
hear
can hear
you.
you.
Oh, maybe it's Miracle I can't hear then. Adenike, can you hear me? I would have loved, because I don't have it here on this my laptop. I would have loved, Adenike, if you can get a sample test plan so that you can show the team how it looks like. But
Okay,
if I get Miracle,
there. We'll still get
okay,
there within
okay,
the
good.
module. We'll get a sample of a test plan. So
All right, no problem. No problem. So I think, Miracle, your question basically is just around the fact that for a test plan, basically, you are not actually listing out all of the applications on that test plan. Even when you want to define, you are listing out, for example, all of the modules to say, okay, for an application, oh, these are the modules we are testing: login, payment, checkout, and all of that. You list them out. But there's a part on the test plan where you are able to now say, okay, for this application, based on the requirements, because you're not just developing it off your head. It's based off of the requirements. You see, okay, for this application, we see that we are doing our regular non-functional test. And then for the non-functional, based on this, so we're not doing security, for example, because there's a team that is handling security. But as I mentioned earlier, as a caveat, as a QA also, you must also pay attention to security in mind. Even though you are not doing it at a large scale, but you must still also pay attention to security, because you cannot also outsource that. Even though it's just at a smaller level where you are looking out for things that are like security breaches that you can identify easily from an application. But because your focus will not be around security testing, you leave that out. You be more of we are doing performance. We are doing performance, we are doing usability, because or accessibility. Because accessibility, I didn't really talk much about it. Accessibility testing is more about this application that we are developing. If your requirement says that, this application, somebody who is deaf, or somebody who is blind, or somebody who is visually somebody who has that disability, one disability or the other, should be able to use this application. You need to be able to factor in that, and there are tools that will help with that. So you also put that in your test plan that, we are doing accessibility testing, because the requirement states that we must cater on for people who are disabled or something like that. So that's what basically. So it's just about, once you get into the lessons where you talk about test plan, you see how it is designed, or you can also check, you see how it is designed, and then you just see that you are not actually just listing out everything. You're just listing out the modules in the application, and then you are now also listing out what are the things we want to test in this application in terms of the non-functional part of the application. I don't know if you get me correct, Miracle.
Yeah, I do.
All right, thank you.
So how Documentation you recommend.
I can't hear you very well.
Recommend like the type.
Sorry, can you say that again? I didn't hear you at all.
Microsoft Word.
Sorry, say that again.
Okay, I said, how about the documentation style?
Yes.
How about the documentation style? Network. Is
Yeah.
it,
Okay.
it's
Most of the time is a Microsoft Word document. Microsoft Word document.
you
I don't know. Is it my network? Hello, can
It's
anybody
not
hear
your
me? Is it my
network.
network or is it my
It's
network?
not your network. It's our own.
Okay. I think I get what she's saying, but I think it's mostly Microsoft Word that we use to document it. I don't know if she can hear me, but I can just drop it on the chat also. Okay, somebody can just help me drop it on the chat. I can't find my chat. Oh, MS Word. The miracle. No, I don't know if I can. Okay, I think okay, I don't find that yet. So I don't know if there's any other question or if there are any other questions. Okay. Okay. So I don't think there are any other questions. Adenike, are you here so that you can take it off from me?
my network was really bad.
Yeah. We've already responded to your miracle. We said you can use MS Word. Most of the time it's MS Word. It's MS Word that is used.
Okay. In the absence of no other question, thank you, Mr. Adewale, for honoring our invitation today. Thank you so much. The session was quite insightful, and we've learned a lot of things. And people like me too, I am refreshed. So please drop your emojis to appreciate Mr. Adewale. So we meet again on Saturday by 12 p.m. Still the same link. So if you're not on the WhatsApp group, I think you can just drop your number in the chat so that you can